made a long video on your lesson for today and it got deleted somehow, some way. So let's just go to it and try it again. How is everyone doing? We're gonna get through this. So we're in this page of your notes, points in 3 dimension, and we've been solving systems with graphing, elimination, and substitution. We are not going to use graphing, but we will use substitution and elimination for 3D. In the video I made, I showed you how to plot points in 3D. In a 3D plane, an XYZ plane, you're not really going to use it anywhere in mathematics other than computer science or calculus 3, because a lot of times in computer programming, you are using 3D because we live in a 3-dimensional world. When I was a child, the first video game I played was Nintendo with Mario and Luigi. And what we did was, it was just back and forth 2D. And then in about 1998, I was 12, Zelda came out and it was 3D. And I remember feeling very uncomfortable with it. It wasn't like my 2D Mario. And I wondered how they did that. Well, they're using a 3-dimensional plane. You take your XY plane and you make it flat, and then there's this third axis called your Z axis. You can fill Z axis in here. And so X represents the front and the back, Y represents the right and the left, and Z is up or down. So if you had this point 3, 5, -2, it'd be 3 to the front, 5 to the right, and 2 down. It'd be out here. But that's just a point. So when you graph it, it's just a point with all these planes. So what you're asking is, when you have a 3D or a 3-variable system, what it would look like graphically. Let me go to this page. You're asking for that point right here. Do you know how hard it is to graph this thing? It's not very efficient. So we're going to use 2 methods today, substitution, elimination. After I show you the substitution method, I want you to pause the video and work on your substitution homework. Then I want you to go back and watch the elimination and then do the elimination part. So substitution, how are we going to do this? We're just going to use these rules, but I'm going to use that example I have because this example is too easy for you guys. It eliminates too many of the variables and I don't like it. So we're going to go and use this example on the back and complete it with this, but we're going to use these rules. It says 1, rewrite the system of 3 equations as 2 systems. Eliminate the same variable in both and solve like the system like normal. So with substitution, you're going to have your 3 equations. It's going to be obvious you're going to use one of the equations and you're going to put it into both of the others. If I pick y versus the x equals, I could substitute y into y, but there's no y here. So we're not going to use this. If I choose x, I'm going to put x not only into here, but I'm also going to put x into here. When I do that, I'm not going to have -3x anymore. I'm going to have -3 quantity 4y minus 11 plus 4z equals -7. So make sure you're doing this on your notes. Okay, it's that second page. And you are simplifying. Now you got to go slow with these because if you don't distribute a negative right, it messes up the whole thing. Okay, and when I clean it up, I like to keep it in standard form. Alphabetical order, and then take the numbers and put them on the other side. So -33 and -7 is a -40. So I substituted to the one equation and cleaned it up. Now I'm going to substitute it into the next equation. When I do that, I'm going to get y equals -20y. Make sure you distribute to get a +55. 2z plus 25. So I'm going to bring y to this side. It's going to be +21. Be careful. I notice students mess it up a lot. If it's just a 1y, maybe put a 1 there. And then 2z on the other side. And then a 55 and a 25 is an 80. So what you did, let's recap. You're going to take one equation and substitute it into both. When you've done that, Now you're down to a 2-variable system. Now you're down to what you've done this whole time. So now we've cleaned up the 1, and we got this equation. We cleaned up the other, excuse me, and got this equation. So when you clean them both up, this is what you're left with, okay?